Hi, I'm Steve Selig, founder of Fit Test, and in this short video, as part of the series of laws of the heart as applicable for exercise professionals, I just thought I'd provide a summary of all of the formula for laws of the heart to bring them all into one place for you to access. So I'm just going over the formula that were in the other videos. So the FIC formula for the heart, which is really talking about the oxygen supply and hopefully oxygen demand and hopefully met by oxygen supply, is the FIC cardiac VO2 formula, which is just equal to coronary artery blood flow times the amount of oxygen concentration in the arterial system minus coronary artery blood flow times the amount of oxygen concentration in the vein draining the heart, the coronary sinus, the main vein draining the heart, equivalent to mixed venous blood for the whole body. So these have equivalents across the whole body. And just to put in the formula for arterial concentration again, which is really important, is that oxygen concentration in the arteries is equal to a very small multiplier of the freely dissolved oxygen, and then a much larger influence of hemoglobin and oxygen saturation, hemoglobin-oxygen saturation. Now, so that means that hemoglobin and oxygen saturation by far dominate the overall arterial oxygen concentration. Now, coronary sinus oxygen concentration is usually very low, which means we can really reduce the oxygen demand cardiac formula for based on FIC to really two elements, and that is coronary artery blood flow and the amount of oxygen in the arteries. Now, in that other video on the FIC that I did, I spent a lot of time talking about these two elements, and I recommend that you go and watch that video again. When we come to rate pressure product, it's a very simple multiplier of heart rate times systolic blood pressure. So that's quite easy, and it's something that an exercise professional can easily measure both at rest and during exercise. And the Laplace Law of the heart, which is oxygen demand, is proportional to wall tension, which is equal to systolic blood pressure times the outside radius of the heart divided by the wall thickness. And again, I've created a whole video on Laplace, and I recommend you watch that video again too. So what I do with all of these laws, and in fact other laws that come into cardiovascular physiology, is that I do a mind mapping exercise with each of my existing and especially new clients. And I try to do a mind map where I visualize and assess and analyze what is happening in the cardiac cycle around pressures, flows and volumes. Rate and rhythm, of course, is also intersecting with the cardiac cycle on the electrical side of it. The valve movements, whether there is normal valve movement or whether there is valvular disease. Coronary artery blood flow is incredibly important, as is hemoglobin oxygen saturation. And I've done a whole video presentation on O2 sats. And also central versus peripheral blood pressures. Now, the beautiful thing about the laws of the heart is they allow us to understand what is going on in the heart, both acutely and chronically. Now, the best example of acutely for an exercise professional is exercise itself, whereas chronic often talks about chronic disease. Now, of course, we can overlay the acute effects of exercise on top of the chronic effects of the disease, and we can apply these laws of the heart beautifully to address all of those issues together. So I think what the formula really do, and certainly have helped me in my practice for a long period of time, is they give me the ability to mind map. They give me a structure in which to analyze what could otherwise be an overwhelmingly complex problem in front of you. So I recommend that you practice. It is difficult to get on top of all of these at once. So I suggest you just start with the law of the heart that is most applicable to your client's situation. So for example, if it's coronary artery disease, you would look at coronary artery blood flow. if it's poorly controlled asthma or a chronic obstructive pulmonary disease or some other pulmonary disease, you'd look at O2 arterial. You might look at hemoglobin in the case of anemias. For rate pressure product, you would look at people with very high heart rates, tachyarrhythmias, or people with hypertension, obviously. For the Laplace law of the heart, you would look at systolic blood pressure again. Now the radius can change chronically with hypertrophy or dilatation of the ventricle, but it can also change acutely with, say, hypovolemia, increased preload, or in the exercise situation where you've got increased cardiac output and increased venous return, resulting in increase in left ventricular end diastolic volume, which will create an increase in the radius of the heart during exercise that you wouldn't see at rest. And similarly with wall thickness can change both acutely and chronically. So I think this slide's very important, and it is to me. It really informs my practice. And what I can recommend to you, this might look overwhelming at the moment if you're not used to it, but just practice on one of these things at a time, and gradually you'll build up the ability to do really effective and quick mind mapping. So I can basically do a mind map for most of my new clients within half a minute. So thanks for listening to this short video, and you can get in touch with me at info@myfittest.com.au. Bye for now.